Hello everyone. In this video I will try to make a point about Newton's law of universal gravitation and the fact that it doesn't apply to actual reality. So the main part of this theory can be explored right here on this Wikipedia page or on other websites. Here we have general data and information about the gravitational model, but we will focus instead on this other site that I found, which has in its name the word dummies, so I guess that everything here must be well explained and concluded even for a beginner. And I must add that this is the same information that was taught during my high school years in physics class. So I have created this small document where I will try to explain my point and talk about this theory of universal gravity. So in the beginning we have this: the gravitational force is the force which pulls all the other objects towards Earth. Okay, can all agree on that? The gravitational force which acts on an object which has a mass denoted with the letter m, which is near the surface of the Earth, is described by the following equation, as we have seen on the website already. This is the equation. The gravitational force equals the product between the mass of the considered object and this letter g, which is called the gravitational acceleration constant. Okay, so this equation, Newton's universal gravity equation, should accurately describe how motionless objects should behave on Earth. And by motionless objects we mean in this case which do not generate any other forces on the surrounding environment. So from this equation we can deduct that heavier objects, which means having a greater mass, should be pulled by the Earth with a greater force. If the object is heavier, and thus the gravitational force which pulls it is stronger, then heavier objects should fall faster towards Earth and should be harder to pull back up. For example, if you want to lift an object from the ground. Okay, so now we get to the part where this equation has problems, which doesn't actually describe how motionless objects behave in actual reality. And for this I will try to provide an example. If we consider an object which has a particular mass, which we denote m1, we know that in physics the equation for the mass is the product between the object's density and the object's volume. Okay, so using Newton's equation we can conclude that the gravitational force which acts upon this considered object is the product between the mass m1 and the gravitational acceleration constant. Okay, this is the first considered object. Now we consider a second object which has the same exact characteristics as the first, which means the same volume and same density, therefore the same mass, which we will denote the same with the same symbol m1. To this object we then tie a large balloon filled with helium, which has its own mass, which we will denote m2. And as a fun fact, let's call it this, we know that any mass can either have a positive magnitude or zero magnitude if the considered volume of space has a density of zero magnitude, which means that it doesn't contain any matter whatsoever. Therefore, so the conclusion is that the mass cannot be negative, cannot have a negative magnitude, which is normal. Therefore, both masses from the example have a strictly positive magnitude, which means the object and the helium balloon. Okay, the ensemble composed of the second object and the balloon, which was tied to it, has a total mass which is the result of the two individual objects' masses summed up together. We will denote this composed mass with the symbol m3. We can clearly observe that the mass of the ensemble is greater than the mass of the first considered object. Okay, therefore, in this case, in the second case, the gravitational force should be, we denote it this time with G2, the product between the mass of the ensemble and the gravitational acceleration constant. Okay, because the mass of the ensemble is greater than the mass of the first considered object, we know that the gravitational forces which act upon them have this relation. In the second case, the gravitational force manifested upon on the ensemble will be larger than the gravitational force which acts upon the first object. Okay, so this is how it goes. This is the conclusion which can be drawn only by using the Newton's equation from using the Newton's model of gravity. But if you perform this experiment in reality in order to validate this prediction, the prediction of Newton's equation and model, you will observe that while the first object will sit motionless on the Earth's surface where it was initially placed, the ensemble composed of the second object and the helium balloon will start to rise towards the sky with nothing to stop it. So this experiment clearly proves that Newton's equation generates the wrong prediction of how these two objects will behave in reality. We will illustrate this experiment with a simple 3D simulation, although it is very easy to picture it in your own imagination. So I have constructed this simple scene and this animation. So this is what happens in actual reality. We have the same two objects, the same density and volume, but the second object has a helium balloon tied to it. So after releasing both the objects and not holding them on the ground, you will observe that the second object will rise towards the sky with nothing to stop it. Okay. So if Newton's equation and model doesn't predict exactly the behavior of material objects, then the same equation and model are flawed. Therefore, the physical laws which are actually in motion in reality are described by a different model. Okay, and to conclude, as a to-do, the sequel to this video should be one which demonstrates how Newton's gravitational model can be substituted with the buoyancy laws described by Archimedes. Because, in my opinion, the buoyancy laws which were described by Archimedes should be enough to predict how objects behave in mediums. Because reality is composed of several mediums, I can argue that the laws which are in motion are the buoyancy laws of Archimedes. So this is the Wikipedia page which contains information about buoyancy. Maybe in the future I will try to do a video describing how buoyancy laws could be used to substitute Newton's flawed gravitational model. So, thanks for watching.